So this is 1.4.1f. We have this nice diagram, some probabilities, and we're supposed to find the probability of A and B if you already know that it's either A or B. So there's two different ways you can think about doing this. And first we'll kind of use some logic in this picture. So it's saying if you know that you're in A or B. So that means I know I'm either in this A or B, or both. So this A or B, the probability of being in that A or B is I would need to add all of these up. So 0.08 plus 0.13 plus 0.06, 0.01, 0.02, 0.05, 0.11, 0.07, 0.05, 0.08, and 0.04. So basically I've added up everything in that red, everything in A or B. And if I add all that up, I get 0.7. So this is kind of like our new sample space. So instead of our entire S that we had before, instead of our entire sample space where the probability of your sample space is 1, instead of having our entire sample space that we care about, we don't care about that anymore. We already know that we're in either A or B. So now our total probability, kind of that we even kind of care about, our whole world is narrowed down to this 0.7. We don't care about anything else, which is going to come into play in a sec. So now we're looking for the probability of A and B. But again, remember, we already said we're narrowed down to this A or B. So we don't care about anything else. We're only looking for A and B. So A and B would be this intersection between A and B right here. So that's going to be this 0.01 plus 0.02 plus 0.05. Now, if I add that up, that gives me 0.08. But remember how we narrowed down our world to just this A or B? So we kind of have to divide it by 0.7 because it's 0.08 out of the 0.7 that we care about. So like kind of 8 that we care about out of the total like 70 that we care about. Or 8 of this, but we only care about the 70, so we do the kind of like 8 over 0.7. Divide that, so we get 0.1143. So that's kind of some logic. You can also try and figure out what it would be if you were to simplify it a little bit more using the formula. So probability of A and B given A or B. So conditional probability formula says you do the probability of an and. So it's whatever you have here, so A and B, and then we'll do an and. I mean, you could do an intersection sign. I'm going to write and so we don't get confused. Whatever comes here, so A union B, all over the probability of whatever was here, so A union B. So you do have to figure out what this top simplifies to. For that, let's draw, to sketch another little picture again. So if here's A, here's B, and we want to figure out where do A and B and A union B intersect. Well, A and B would only be this little piece here. A union B is everything. So where did those two things intersect? Right back here at the intersection. So that's going to be the probability of A and B over this probability of A union B. So coming back up, probability of A union B, that was when we added everything up. That was our 0.7. And A and B is everything right in here, which is our 0.08. So we get back to the same answer.